We're halfway there. We're nearly there. We're halfway through the assignments. We've finished now and handed in assignment 5. So there's only 5 left to go. I want to take this time to just say how impressed I am at all your hard work. I know it's tough, but I promise you it will pay off in the long run. I especially know that the documentation element of this work may seem a little tedious, but it will definitely help you as well, just to go through that process of analysing your own solution and kind of ensuring that you fully understand what's going on there just by writing this little short description, and also practicing some nice techniques such as class diagrams and pseudocode, which should be useful for you going forward. So I'm not in no way trying to torture you at all. I'm doing this all for your development as programmers, and it's exactly what I did at university: documentation and assignments, 10 of them across the term, and I feel like it really helped me. So this is exactly why we're doing this. But we're halfway there now, to be honest, and I should imagine that given that the first few assignments are there just for you to learn what's going on, I should imagine that we're really through the worst of it. So this week we were looking at planes, looking at this idea of a plane heading towards a destination, and the little blurb in assignment 5 read as follows: we would like to create a simple simulation of an aeroplane travelling to various destinations. An aeroplane may travel to a single destination which will cover a certain distance. It may also travel to multiple destinations over the course of a single day. Moreover, it can repeat its daily journeys over a number of days. After the aeroplane travels a certain distance, it is a requirement for it to be inspected for repairs and as a safety precaution. This process takes 7 days, during which time the aeroplane cannot fly. Model this scenario based on the following requirements. So again, top to bottom, completing these requirements. Maybe jumping around a little to do some tests. That's not a problem. Or a technique that I saw someone tell me this week was they would fill in the method. They would make sure the method returns something, then they'd skip ahead. That's not too bad an approach if that works for you. But again, you should definitely fill in the interface, so the methods that we're looking for, before continuing onwards with a brief. Model this scenario based on the following requirements. The location of a destination or an aeroplane at any point in time is specified via coordinates, or a coordinate. This has an x, which is the value along the x-axis on a map of the location, and similarly a y, for the y-axis. These are both whole numbers. So I could almost speed up here, but I won't, just to show that we can do everything, because this should be now quite a familiar process, building a class like this. So we know what the class has to store. We know we want to be able to get it back and put some information in there. So we're going to have this coordinates class, and I know it's going to be defined by 2 fields. So I'm going to go quite quickly here because we've looked at this so many times now. I really hope this is familiar. Private fields, always private, unless there are other restrictions there. And a nice constructor, so coordinates, allowing me to specify these values. So this dot x equals x, this dot y equals y. And then I'm going to put in some getters and setters. So a good way to write a general class to begin with is to add a constructor in, add the getters, add the setters. Then maybe later on you want to evolve this class by changing that constructor in some way, maybe removing the getters or setters if they're not needed. But for now I'm going to start, I think I did an opposite approach last time. I kept my classes quite conservative, but this time I'm going to instead make them quite verbose, and then come back and maybe make them shorter later on. This is just to show you a different way to approach things. So here I'm going to have my getX, which is going to return x. Of course, I'd need a return type there. Return x. I'm going to say public int get y. It's going to return me a y, and then public void set x int x. Dot x equals x, public void set y, int y, dot y equals y. Yeah, so just a standard class. Again, I've made it quite verbose this time, just to approach this just to show you a different way you might think about solving these assignments. I'm going to put quite a lot of verbosity in here for now. Maybe slim it down later on, or add other constructors, or change this constructor if I need to. That's 1.1 done. A destination represents the town or city that an aeroplane can travel to, and it has a name and coordinates. So straight away I'm seeing now I can use this coordinates class to build up or compose another class. So I know that a destination has a name, so straight away now I'm going to employ my my new string class, string type, this special primitive type that we talked about last lecture that's actually also a class type. And I'm going to employ my own custom type now, which I know is coordinates. I'm definitely going to spell coordinates wrong at some point in this video. It's just one of those words that my fingers never type properly. So I'm going to say destination. And again, I'm going to assume that I'm going to need some kind of constructor here. So I'm going to, at least at first, until I know any more, I'm just going to put this in there by default. Might need to take it out, might need to alter it, might need to add other constructors. But for now, I'm just going to assume that that's all fine. So this.name equals name, this.coordinates equals coordinates, and then the old getters and setters. So get name, return name, set name. There we go. Coordinates, because of course I can return a coordinates object back. These should still be private, right? Although they're fields of a class type. So effectively they will eventually, under our current understanding at least, hold objects. They'll become objects. We still keep them private. Okay, so the general rule is anything that appears outside a method, if it's a field, should be private. Okay, which is why I encourage you to only really declare variables or fields outside a method and do everything else inside the method, so we can keep this idea of keeping everything private consistent. So get coordinates, we're going to return coordinates, public void set coordinates. Again, won't necessarily need these, might come back later on and slim these classes down, but just for now to give you that extra bit of verbosity, I'm going to leave them in. Okay, that's destination done. And now you'll notice, I mean, hopefully this is clear, but I'm not adding any comments into these classes. You should be doing so. So as you're typing this code out, you should be adding comments for yourself to explain exactly what everything does. This will really help your development, your understanding. It's also something to be said for doing comments while you write. So, I mean, I guess coming back to this point about people finding the documentation quite tedious or time-consuming, if you're writing comments as you go, you then don't need to think about them as part of the documentation. So write the comments as you go, even if you maybe remove the lines that they're associated with, type the comments as you go, and they'll be there ready when you come to document. Same principle for pseudocode. So before I would even come to this solution, I would really have to sketch out what I think the idea would be, and I've seen lots of you doing this this week on kind of rough bits of paper. By all means, scan them any way you like, take a picture of them, pop them into your documentation. That would be fine for pseudocode. We just want to see that you're able to design a solution without actually using any Java code. So if that's in a document, if this is on pen and paper, we want to see that. We want to see evidence of that skill, because it's so important that you always think about going to paper or to some kind of planning mechanism, like typing some notes out for a solution before you dive right in, especially for complex programs. Which I think assignment 5 was in that respect. Okay, so a little bit of a digression there, but hopefully you see my point. So comments as you go, pseudocode as you go, really try and incorporate the documentation along with your code development process. Just keep things really, really a lot easier at the end, and it'll stop you kind of rushing to submit your documentation after you've done your code. Destination done, so that's good. And now on to aeroplane, so 1.3. So again, I made these classes beforehand just to save a bit of time. We know an aeroplane has a name, so again, we're using our nice new string type. We know again, like destination, aeroplane has coordinates. And now we know it has a speed, which I know is an integer. I know it has a total distance traveled. Yeah, and I know it has a repair distance. Okay, and again, I will assume that this is passed via the constructor. Might come back later and change this depending on what we find. So actually, let's do the old speed up and see if I can pull out some more comedy music. Okay, there we go. Get name, get coordinates, get speed, get total distance, get repair distance, set name, coordinate, speed, total distance, repair distance. Perfect. All right. So again, not sure. I've not got further enough in the brief yet to know whether I'm going to need all these getters and setters in the constructor, or whether I'm going to need to make the constructor more flexible. But for now, it's nice to have the flexibility ready for us if we do need it, and we can delete stuff later on if we don't. So that's 3. So now 1.4. So again, I said that there were parts of an assignment that were always that little bit trickier, that would constitute, say, the final question in an exam where we'd really push you. And this is typically this kind of question. So an aeroplane can take a single flight, which will attempt to move the aeroplane towards a supplied destination. This will also calculate and return the distance travelled in this single journey. The aeroplane moves towards its destination as follows. The aeroplane keeps moving towards the destination, changing its position every hour until its x-coordinate matches the x-coordinate of the destination, and its y-coordinate matches the y-coordinate of the destination. So I'm not going to need this method inside aeroplanes. I'm going to put it above all my setters because I feel like it's probably quite important, and it's going to be called single flight. So it's going to attempt to move the aeroplane towards its destination, and this will also calculate and return the distance that the aeroplane has travelled. So I know it's going to return some integer because it's going to return the distance that's travelled in that single journey, and I know it's called single flight. And I know that it has supplied a destination, so of course that suggests if you want to supply something to a method, it needs to be a parameter. So I know it's going to have a destination like this. There we go. And then I know I'm going to need some kind of logic inside here, just to get rid of that red line. I'm just going to return -1 for now. Again, remove me. Remember we did this last time, just so we can keep Eclipse happy in terms of the errors here. So as I said earlier, maybe you would have liked to leave this to last, so you could have gone on then and done the rest of your program with this return -1 in there. This is what I was talking before about, before even when people were telling me they'd left in just the names of the methods so they could call them, but not actually put the logic in there. That's fine, not recommended necessarily, but if you must kind of leave things to one side and then carry on, you can do that. But make sure at least that you fill in the interface here so you can at least build a somewhat complete solution that would be able to call this method. It just wouldn't do exactly what you wanted it to do. Okay, so I want to talk about the notion of flight that we were trying to kind of communicate in this assignment. So you'll have hopefully seen the little graphic that I produced, showing a plane heading towards hopefully a familiar island for some of you who watch too much television, and we kind of saw this plane progressing. And the notion that we were thinking about was that we have 2 points. So we have this XY plane, only in the positive region. So the top right quadrant, I suppose you could imagine. And there would be a plane at one point, and there would be a destination at another. And in fact, you know what? Let's actually make this. So let's do what I said. So we've put in single flight here. So let's jump ahead a little. And fill in our planes. We can actually build some objects and see what we're talking about before we jump into this single flight method. So again, if you've built, as I say, if you've built the method, you built the interface, you haven't quite got the logic right, it's okay to jump ahead. Not necessarily advised, but we're going to do that for our purposes. So I've got this flight simulation class. Again, I'll come to this formally in a second. But for now, let's make some objects. Okay, so we want to make some destinations, want to make a plane, then we can talk a little bit more concretely about what we want to do. Okay, so this flight simulation, it can be compiled from the command line, and we want to use the classes and methods that we have already. So we're asked to make a destination. So we call destination. We want to call the variable holding it destination1. Yeah, we call this new destination. And I want the name of the destination to be Buenos Aires. And I want a coordinate of 110 and 135 in there. Okay, so I look at the constructor of my destination and I can see it accepts a coordinates. So I have some choices here, and these are choices that I did talk about in the hints and tips video. My choices are as follows. If I strictly go with the rules that we've been talking about, the rules of thumb, which say that object creation should mainly happen inside the main method, then I'd do something like this. I'd say coordinates, so I'm making my coordinates class, coordinates. We could say destination 1 coordinates equals new coordinates, yeah, and I could then enter the plane's coordinates as 110, 135. So don't be put off just because it says that, that a destination has an x and a y coordinate. It doesn't mean that you have to supply that information directly. It just means that inside that destination object, in those fields, should be somehow be stored those values, whether they're wrapped inside an existing object or whether they're just direct. Okay, so when I say I want a destination with the name Buenos Aires, that means I want Buenos Aires stored inside here. And when I say I want x coordinates at 110 and 135, which are my numbers here for 2.1, the destination 1, that doesn't necessarily mean I need to store x or we're asking you to store x and y directly. It means that we want to naturally, because we've asked you to put a coordinates field or a field of type coordinates inside destination, it means that we would somehow want you to wrap the x and the y in a coordinates object and pass that through to this destination. So as I say, the most natural way to do this, following our rule of thumb, is to pass it through like this. There are some alternatives. So I had seen some people doing this. So they would take this need for x and y to be supplied quite literally. Yeah, they'd do this. And you could then change your notion here. So you remove this idea of the destination. You put 110, 135. But again, remember back to the hints and tips video. This is perhaps a somewhat a risky thing, because then I was seeing some people doing things like this: coordinates dot set x, x, coordinates dot set y, y, and then people were kind of running their solutions and coming up with these errors. Okay, again, as I said in the hints and tips video, which I'd recommend you go back and watch if you haven't watched it already. Quite nice, I think, even if I do say so myself, that video, because we looked at some common errors and some nice ways to debug your code. And one of the first errors I talked about was this idea of trying to access a field without first putting an object in that field or transforming that empty field or variable of a class type into an object by assigning a class copy to it, at least under our current understanding of what's going on there. So again, as I say, if we were to focus on supplying the values directly, then we open ourselves up to this risk of this happening, which is yet another reason why it's nice to follow this heuristic of defining coordinates objects inside the main method. I'll talk a little bit more about that in the lecture on Thursday about what's going on here. But as we saw in the solution video, if we wanted this to work, we'd have to say coordinates equals new coordinates like this, wouldn't we? Yeah. And of course, because I have a constructor there that says I should supply x and y, I can just put x and y in here like this and actually forget the notion completely. And I knew I was going to spell that wrong at least. If those of you are counting, I've done it again. Coordinates, goodness me. Yeah, so we can tally that up as the first, second, maybe time I've misspelled that, goodness me. So there we go. So we would assign this new coordinates object to that field using the x and y values that we've passed through. There we go. Okay, so that was another way to do it. Again, because there was this potential for error by not having assigned an object to that field, as we might think, the recommendation was still to pass the coordinates through like that. Okay, so I'm actually going to switch back to my original version, which doesn't involve making a coordinates object inside the class itself, because again, this is something else we'll talk about later on in the course. If I make objects inside classes rather than inside the main method, if one class is solely responsible for the creation of these objects, or a group of classes are solely responsible for the creation of objects, a destination would be responsible for creating coordinates, and that does have some implications in terms of the design of our program, and I wanted to look at that more formally before we necessarily do that in the assignments. But again, no marks lost for that. It's an acceptable way of doing things. But of course, I don't even really want to talk in terms of marks. I want to talk in terms of feedback, which is why you're here. Right, so we could then do destination 1 coordinates like this. There is a third way, a way which is okay, which is the way I would do it, I think, actually. Not necessarily given the point that we are currently in the course, so this is what I would actually stick to be honest, for now. There is a third way, which is quite nice. Remember, we talked about it in topic 6, we talked about how our understanding currently of the relationship between objects and variables is a simplification. And because of that, there are some techniques that we can do that might not fully make sense at this point in the course. So something we can do is this. We just, rather than assigning a new class copy directly to a variable, we instead create that class copy, pass it through to destination, and then do the assignment later on. So this is basically just a stretched out process of the normal single line declaration, like the one that we had before, except rather than declaring it, creating this copy and assigning it to this variable such that it becomes an object directly, we do this kind of via the constructor. So this was another kind of valid way to do this. And we'd create this class copy, as you can see, and it would kind of ping through here, ping down there, and then be assigned. So again, it's just a multi-step process of the normal assignment of this copy to a variable in order to create an object. So that was another valid solution. But again, I'm going to stick with this because I think that's fine for now. And then there were a couple of other destinations as well, but I want to skip forward and just imagine I have my first destination for now. Well, actually, my aeroplane starts at that destination, doesn't it? So let's do one more destination. Let's say coordinates, destination 2 coordinates equals new coordinates. And this time my destination is Muscat, and it's going to be 5 and 30. Yeah. Destination 2 equals new destination. Call that Muscat, and then again, I'm going to say destination 2 coordinates. So 2 coordinates objects now. And now that we're going along, we might as well make the third one too. So coordinates destination 3 coordinates equals new coordinates, and that's at 105 and 25, at least in my brief. Then destination 3 equals new destination. This is going to be Zanzibar. And this is going to be destination 3 coordinates. Alright, and then to my plane. Okay, so aeroplane, plane equals new aeroplane, like this. And again, now we've got a different constructor. So what am I doing? I'm basically, if you're hopefully following, we're on 2.4 now. So I know I've kind of skipped over 1.4 for now. I just want to show you the interaction between the objects before I get to that. And this, I'm okay to do this because I've kind of created the right method, the right interface, what it returns, what it accepts. I'm just returning a dummy value for now, -1, to remind me. So it's okay to skip ahead in this small way. Again, not advised, you should really try and do the assignments top to bottom, but when I'm explaining things, I think it's okay for me to jump like this. So my aeroplane expects name, coordinate, speed, distance, and repair distance. So we're going to say Spirit, which is the name of my plane, and X coordinate and Y coordinate. Now I saw lots of errors here, which was again logical errors. This is, which was again actually quite subtle. So no problem if you made this kind of you had this issue. But I saw lots of people doing destination 1 coordinates, repeating it again, right? So they wrote destination 1 coordinates down here. This is quite a subtle point, and again something I drew your attention to in the hints and tips video, so I'd recommend going back and looking at that if you want a fuller explanation of this. But unlike primitive values, which we can pass around our program and know that they will safely be passed by value, so we can't ever manipulate their original values. So if we take a variable, for example, and pass it to a method and interact with or change that variable inside that method, then the original variable will remain unchanged. The rule is different for objects. Again, this is for reasons that we'll see very close to the beginning of next semester. But for objects, you can just remember that, or think that they are effectively passed themselves rather than this copy that won't affect the original object. So if I were to pass an object to one method and then manipulate it in some way, and then pass that same object to another and manipulate it in some way, or even better, if I were to take an object and store it in one class and then store it in another, and if I manipulate that object in the first class, it will affect the stored object in the second class. So effectively, anywhere I interact with an object in my program will change every reference to that object that I have. Again, if that's not clear, go back to the hints and tips. It was the very last point that I made. We looked at this pair balancer and this strange behavior you'd get if you tried to pass the same pair to the balancer twice. And you can see the same principle here. So it might be tempting to think because the plane and the first destination, where the plane starts or where it will return to at the end, because they have the same coordinates, it might be tempting to just copy and paste destination 1 down here. But some of you will have seen that will have created unexpected behavior because we need to have them as independent objects. Just because if I were to use destination 1 here and change the aeroplane's position, which I know I want to do, by changing the value stored inside this object, it would also change the location of Buenos Aires. And I'm pretty sure that's going to stay still. So we don't want to use the same object here. We actually want to define ourselves a new aeroplane coordinates object. So new coordinates 110, 135. Yeah, so this is a nice little reminder of something. We did look at this in the notes. We saw some examples of it. I talked about how the behavior for objects was different. We looked at this automatic book reader, which would take a book and change its pages, and then the original book would as well be changed in the main method. So aeroplane coordinates, and then speed. Things are quite normal now. Distance is 0. Again, we know the field defaults to 0, but it just gives us that extra little bit of flexibility. Imagine we wanted to create a plane, then represent that it had already done some traveling, so having this information supplied is actually quite nice. Okay, so again, we know this would default to 0 because it's just an integer field. But again, just for this flexibility, we're going to actually manually have the ability to specify what the distance is. We could have sort of created a second constructor, which wouldn't have accepted the 0 there. Second constructor, allowing me to perhaps more efficiently make a plane if I don't want to give it an existing total distance. But this is fine for now. Just reflects this flexibility. Right, so the whole reason I kind of jumped here forward to flight simulation was to show you exactly the kind of behavior we're looking for. So my plane starts at 110 on the x-axis. This is an x value. Remember, we're talking about a positive kind of 2D plane here. And it starts at 110 on the x and 135 on the y. So the kind of flight behavior that we're looking for is if we want to move our plane, so we want to say plane.single flight to destination 2, which is Muscat, then we want to move the plane's coordinates from 110 to 5 on the x and 135 to 30 on the y. So we want to decrease the x position of the plane and decrease the y position of the plane. Now, if we were talking about true geometry, as in these were just single points on this 2D plane, x and the y for the plane here, x and the y on the plane for Muscat here. Actually, let me take a step back. So remember, we don't just want to move the plane to this position. We also want to track how far it's moved, because the purpose of tracking it is to work out when we want to repair it, right? So we want to track how far the plane has flown. So we need that to be something that's tracked as part of our plane's movement. So if we were talking about true distance, then we wanted to work out how far is it from for the plane to fly from Buenos Aires to Muscat, then we would just kind of take this Pythagorean distance, wouldn't we? But to make things a little bit more complicated, I guess, to kind of keep the focus for this assignment right, given what we've worked on, we said we weren't going to work with this true notion of points distance. Instead, we were going to introduce a different idea in that the plane moves in both the x and the y by a certain amount in order to finally reach its destination. So each kind of unit of movement, the plane can move in the x a certain distance and then move in the y a certain distance until the x and the y meet the x and the y of where we want to go. Yeah, and then as part of doing that, we track the distance. So it's this notion of taking a slight permutation. I think it's some kind of it's similar to the Manhattan distance, as opposed to this geometric Pythagorean distance. That's the kind of thing we were working with. So effectively, you could have solved this assignment if you were talking about true Pythagoras, or maybe even this Manhattan distance. You could have solved it in 2 lines. Or at least solved this single flight method. You could have simply done the subtraction here to work out how far it moves, added them together and returned it. You could have and then just set the x and the y of the plane to be equal to the destination. That would have given you the right numbers. Of course, we're not just looking for the right numbers here in PPA. We're looking for actual demonstration of your programming ability. Okay, so unfortunately, that will be quite a few marks lost if, again, I don't really like talking in terms of marks, but just as an aside, if you did just do the straight calculation, because remember we had this note in the assignment saying that we don't want to just use geometric distance, because we want to make things that little bit more interesting. And also, remember we said the way to maximize your marks was to manually do this calculation. Okay, so I guess the more natural mathematicians there might have been screaming a little bit at this because it was quite simple if you just use this kind of closed form solution. But again, we really want to kind of force you to practice and show us that you're comfortable with loops and if statements rather than doing this kind of closed form solution. So that's the kind of behavior we're looking for, and you can see this again in the visualization. So the plane heading towards this certain famous island. You can see the kind of movements and the values there. So hopefully that was useful for you. You can see the kind of behavior and the things that we want to track reflected in that little document, hopefully. And I would advise you again, if you weren't sure about anything that I've just said about the movement, to look at this little PDF, look at the way the plane moves and progresses. So one thing I haven't talked about, which is the influence of hours. So I know this was quite contentious, but hours are important because they show us they have some relationship to speed, right? So my plane's speed here is 12, and remember this says that in the brief it says that this is how far the aeroplane can move in 1 hour on both the x and y axis. So we can imagine, for example, if my plane speed is 12, then it moves at 12 miles an hour. Yeah, so there's this inherent relationship between hours and speed, hours and time, which give me the speed. So I know I'm told that I need to kind of segment the movements of my plane into hours. And again, you can see this from the graphic. You can see there's a maximum distance that the plane can cover based upon this speed value, 12 miles in 1 hour each hour. So I know this is going to have some kind of effect on my calculations, and I'm going to actually need to repeatedly move the plane hour by hour to get closer to its destination. All right, so I just really wanted to talk about that to kind of show you that that thinking. This is the kind of what you needed to extract from this brief. Maybe draw yourself some diagrams. I know I drew a lot myself to help people. Look at the diagram we've given to kind of work out before you've even written any code what is the kind of behavior that we're looking for here from a plane. All right, so let's tackle this now. So we need to say if the plane is at a certain x and y, so if it's at 110 and 135 here, it needs to be at a different x and y, 5 and 30, and it can only move 12 units of distance. We can say 12 miles every hour, very slow plane indeed. Then we need to kind of reflect these increments. We need to kind of repeatedly move the plane as far as we can in these hours. Okay, so we're kind of, even if you weren't okay with that notion, you kind of directed to this in the brief. So if we go back to 4.1, so it says the aeroplane keeps moving towards the destination, changing its position every hour until the x and y coordinate, the x coordinate matches the x coordinate of the destination, and the y coordinate matches the y coordinate of the destination. So back in aeroplane, before I do this, I just wanted to say I saw some people inputting an aeroplane in here. So aeroplane. No need to do that at all, because remember, this is the flight of this aeroplane. So any objects of aeroplane that you call single flight on will manipulate and update that aeroplane itself, so no need to pass an aeroplane in there. It can refer to itself, which is fine. And the functionality that I want here, again, as I've said, I want to determine over these units of time, I want to move the plane towards a certain position. So again, I'm just following the brief strictly here, but I've also got this idea of something about hours in my head, so I've kind of reconciled these two things into knowing that I'm going to need a loop. So I know that I have to keep the plane moving towards its destination, which implies a loop. And again, I've got this idea of hours, these repeated units of time where the plane's position can change. And I found that out by looking at the little graphic that we have there. So I can imagine that we want to keep moving, so we want hours to keep progressing, while it's the case that the position of the plane is not equal to the position of the destination in both the x and the y. So the conditions that we want are that the position of the plane, which is just coordinates, access the coordinates field, get the x. While that's not equal to the destination, get the coordinates, get the x. So you should be familiar with assignment from assignment 4 now about building up these calls to objects and then calling the methods on them. So this returns an object which grabs me the x. This here references the object field. So I saw some people again saying get coordinates. That would have been fine, but remember, because we're inside this class, we can just reference the field directly. So we can say coordinates.getX. And there was another condition that I wanted, which was, again, coordinates.getY not equal to destination.getCoordinates dot get y. So these are the two conditions under which I want ours to keep progressing. Well, I still want the plane to be in flight, and obviously it's in flight over periods of time. I want to keep the plane in flight while these conditions are the case. So I need to connect them somehow. I want to connect them somehow. What I'm going to do is I'm going to connect them with an OR. Okay, so I'm going to say if it's the case that the x is not equal to the y, or the y is not equal to the y, I want to keep the plane moving. Why am I using an OR here rather than an AND? Well, we can see if this was an AND, remember this notion of short circuit evaluation, if it were the case that I were to update the position of my plane and suddenly the x of the plane was equal to the x of the destination, then with this AND behavior, this would become false, because imagine now the position of the plane was at 110, moving towards 5. Imagine if the x position of the plane becomes 5, so is it the case that 5 is not equal to 5? No, that's false. This would evaluate to false in whatever construct I'm about to put it in, and then it would drop out the loop, wouldn't it? So I could end up with a situation in which the x of the plane is equal to the x of the destination, but the y of the plane is not equal to the y of the destination still. Okay, because remember, with the lazy evaluation, the short circuit evaluation, sorry, I should say, this loop will drop out early there, and we won't always keep going until the y coordinate is correct. So I wanted an OR here because I want two things that need to be correct while I'm still moving the position of the plane. And I want to stick these in a while loop, right? A big while loop that says while these coordinates are not the same, keep going around, keep manipulating the plane, because I don't necessarily know off the top of my head how many iterations I'm going to need, right? Because again, remember I said while loops were useful when we don't necessarily know how many, as I say, iterations we're going to need, and this is one of those cases, right? We could work it out, I guess, if we looked at our numbers. We could think carefully about how many loops am I going to need to actually move the plane to its destination. But in general, if we have to do too much work to kind of calculate that, we can kind of just leave this in the hands of Java, right? We can say, quite simply, keep doing what we need to do here, keep moving the plane, as we're going to see in a second, keep doing that until these conditions are met. Okay, so it's almost a kind of lazy but useful way of abstracting away this idea of trying to work out how many iterations we need. We wouldn't use a for loop here or anything like that. Because again, as I say, we don't know the number of iterations we're going to need, or we don't care to calculate how many that is. We're just going to leave it in the hands of Java and say, while it's the case that these two conditions are true, so they're not equal, we're not in the right place, keep updating the plane. Okay, so we need a nice while loop there. And again, that was something that would have been sort of guided, or the brief would have guided you towards, in that we want to keep updating, keep changing, while it's the case that these two conditions are met, which is that the plane's not in the right place. All right, hopefully that makes sense. Always contact me if it doesn't. You must do, because remember, these videos are really perhaps the most important part of your assignment feedback. This generic feedback is really important. But let's move on to 4.2. So the x-coordinate of the aeroplane is adjusted as follows. It will increase or decrease depending on whether it is lower or higher, respectively, than the x-coordinate of the destination. Okay, so we know that the plane is the x is going to increase. So if the x increases, it's effectively going to move right. Yeah, so it's going to go to the right, because if we imagine we have 0 on the left, then if the plane is, for example, I think it was in the simulation, wasn't it? So, oh no, this moves backwards. But let's imagine the plane would be at 5 and 30. So its x is 5, and the destination of the x is 110. And if we think a lot about a straight line on an axis going from 0 on the left and whatever top value on the right, then we know the plane would have to move right, wouldn't it? Because it's going from 5 to 110, so it moves across the screen from left to right. Okay, so we know that if it's the case that where we want to be is greater than where we are now, then we're going to move right towards it. Okay, and then the same process in reverse. If the plane's at 110, let's imagine, and it wants to move to 5, which is exactly what it's actually going to do here, then it's going to move left, isn't it? Because it's 110 up here on the right, 5 on the left, so it's going to move back along towards the origin here, we could say, on the x. Okay, so we're just thinking about the x for now. We'll think about the y in a second. So that's the behavior that we want. We want to say if it's the case that the plane needs to move left, then move the plane left. If it's the case that we want to move the plane right, then move the plane right. Yeah. Okay, so remember the first, so let's try this. So that we want to move the plane, if it's lower, if the position of the plane is lower than the destination, then we want to move the plane right, don't we? Okay, so start off, so we say if coordinates.getX, if where the plane is now, yeah, so is less than the destination, yeah, if this is the case, yeah, so remember coordinates.getX, so let's imagine the plane is at 5, so that's its x position. Let's imagine it's in Muscat and it wants to fly to Zanzibar, for example. So it's at x, which is 5. So 5 here in coordinates.getX. It wants to move to Zanzibar, which is at 105. So is it the case that x, which is 5, is less than 105? Yes, it is. Well, that means it needs to move, the x needs to increase, doesn't it? Because it's at 5 right now, and it needs to move up to 105. So I actually want to add to the x coordinate of the plane, don't I? So I want to say, wherever the plane is now, move it right. Yeah, because it wants to go from 5 to 105. Let's imagine Muscat to Zanzibar. So I want to move the plane to the right along the x-axis if it's the case that where I want to be is greater than where I am now. But of course there's a restriction here, so let's actually first of all look at actually changing the position of the plane. So we say coordinates.setX. Yeah, we want to say coordinates.getX. Remember this idea of updating something by taking what's already there and then adding something to it. Yeah, so we want to say we want to move the plane in some way. We want to increase. So we've got this plus. We want to move it from left to right in some way by some distance. So we know we can with this destination here. Yeah. So then we can say, but we've got this restriction, haven't we? So there's only a certain distance we can move it from left to right. Up the x-axis, we might say in this way. And that maximum distance is its speed, isn't it? So the plane can only move from left to right towards its destination, remember, because where it is now it is less, it's further left. It needs to move right towards its destination, and the distance that it can move right to get to this destination is restricted by its speed. Yeah, so it wants to move right towards its destination. The other circumstance, which I'll spell out as an else if, but we can reduce it to an else in a second, is that the actual destination, where we want to be, is actually let's just leave it the same way around. So we say coordinates.getX is greater than the destination .get coordinates.getX. I missed out some brackets there. X there. Okay. So this is the reverse idea, right? So where the plane is now is greater than where we want to be. So let's imagine that, for example, flying from 110 to 5, we know we're at 110, we want to get to 5, so I know that effectively if 110 is here and 5 is way back down here towards x, towards 0, towards the origin here on the x-axis, then I know that I want the plane to move left, don't I? I want to decrease the plane's position. Right? So I need to do the opposite. So I need to say coordinates.setX, coordinates.getX, minus speed. All right. And again, I might come back later on and shorten this down, because obviously these are just two separate conditions, so I could strictly make this an else, which would make things a bit more straightforward. All right. It's a very, very similar principle for y. So let me just summarize what's going on here. So I want to keep going. I want to keep looping inside this while it's the case that the position of the plane, let's just think about the x at first. The x of the plane is not equal to where I want to be. Okay, so we want to imagine, first of all, let's say I'm at 5 and I want to get to 105. So the plane is at position 5 on the x-axis. My destination is at position 105 on the x-axis. So I want to move from left to right. I want to move right. I want to go up the x-axis towards a higher number. Then I can catch this condition by saying, is it the case that where I am now, say 5, is less than 105? It is. So I want to increase the x position. I want to move right. So I want to add speed. That's the restriction that I can do within a single unit. So we can imagine this is hours passing. Yeah? So that's the reason for using hours. It segments this plane's movement. This is 1 hour. Each loop iteration that goes round is 1 hour passing. And then the opposite is the same here, right? So if I want to go left instead, so my current plane's position, say it's in 110, wants to get to 5, needs to go left, doesn't it? It needs to decrease its x value in order to get closer to its destination. So I'm going to minus the speed there. Very similar principle for y then, almost exactly the same. So get y. So if the y is less than the destination. If that's the case, if the y is less than the destination, then I want to move up, don't I? Because if, let's imagine here, I'm at 30, so imagine my plane's at destination 2, want to move back to destination 1, so I want to go from 30 to 135, then where I am now, the y where I am now is less than the destination, isn't it? So I want to move up the y-axis, I want to increase my y value. So from 30 again towards the bottom of the y-axis would be 0. I'm at 30, I want to go up to 35. So if it's the case that that's true, so obviously 30 would be less than 135, I want to move up the y-axis, and again I want to change the coordinates of my plane, dot set y, to be whatever the coordinates of the plane are now, plus speed. Okay, so it's the speed that you can move in either the x or the y direction. Simple again, else if coordinates dot get y again. If I'm now greater than destination, so I'm above the destination, I want to move downwards on the y-axis. Yeah, so I'm too high, I'm above where I want to be. So flight simulation here again, imagine I'm at 105, sorry, no, I'm at 135, I want to move down to 30. Yeah, so I'm at destination 1, want to move to destination 2. Then I'm higher on the y-axis, and I want to move downwards towards 30. So I'm going to say coordinates dot set y, coordinates dot get y minus speed. Okay. So this was the basic idea, this is the basic thing that we were looking for. There is a little bit more complexity still to come, but this is the basic thing that we were looking for. So we want to see this kind of logic. So I can just comment this. So this is moving right because I'm adding to the speed on the x. This is moving left because I'm subtracting from the speed on the x. This is moving up because I'm moving up on the y, and this is moving down. Yeah, that's good. So I've kind of mixed 1.2 and 1.3 here, but I've left out one of the key bits of complexity here, which is this idea that it's not always the case that we can move the plane at full speed. So as a plane is approaching its destination in units of each hour and units of speed, it might not be the case that the distance between where I am now, the plane's position at the start, and the destination is divisible by the speed, so, or wholly divisible, which means that towards the end, if the plane were to keep moving at full speed, it might overshoot its destination, right? So if I keep adding 12 onto my plane's position each time, eventually it might overshoot where it wants to go. So we need to carefully check this. We need to see, is the distance between where I am or where I am now and where I want to be, is that less than the speed? Yeah, if it is, then I want to simply increase the speed by, effectively jump my plane to its destination and record the distance traveled as I do. Okay. So I'm going to say this, I'm going to say if, so I'm going to look at the destination position, I'm going to say if I'm at x here and I want to move to y here, then what is the difference? I want to say what's the difference between here? Okay, so if I imagine I'm at x 5, so is it, yeah, 5 is less than 110. And what I want to do is I want to carefully calculate this distance. I want to organize the operands to any subtraction to calculate this distance such that it's never the case that I get a negative number. So remember I encouraged you to avoid the use of math.abs. It wasn't needed because it could perhaps allow you to kind of get around using some of these conditionals, and we really wanted to test your use of conditionals again. So we asked you to kind of not use this more advanced syntax again. Remember, we're not looking for the most elegant solutions, we're looking for those solutions that allow you to show us that you understand where we are in the course right now. So as much as we'd love to give you the freedom to make the most elegant solutions, so in CW4, for example, might have been nice to use inheritance, but then maybe you wouldn't have been able to show us that you completely understand the way in which objects might be used in this simpler way. Okay, so not always looking for the most elegant solution, looking for a solution that matches what we want to do, or what we want you to show us now. Right. So imagine again I'm at 5, so my x position is greater than 110. I don't want to subtract 110 from 5, do I? I want to subtract 110, 5 from 110, right? So I want to take my destination, I want to subtract it from where I am now. So I want to say if destination dot get coordinates dot get x, yeah, minus where I am now, if that's less than the speed, yeah, so if the distance, so imagine I'm approaching, slowly, I'm approaching my destination, so I'm moving from Muscat to Buenos Aires, and I eventually find that the remaining distance between Muscat and Buenos Aires, now I'm going in units of 12, so from 5 up until 10, I'm eventually going to see that that the position I end up in is going to be, I'm going to overshoot, aren't I? So I might end up in the case that the distance between Muscat and Buenos Aires is less than the speed. Okay, and in fact, why don't we test this out to see this kind of behavior? Right. So I'm going to take this out for now. Okay, this is a really good way to test. Okay, so let's take this back a notch. So let's imagine that I now want to kind of, I've written quite a lot of code here without really testing anything, haven't I? So I might think, I just want to take a little bit of a step back. I want to take this out, so I've kind of got an idea of where I'm going, but I want to kind of prove to myself these principles that I'm interested in. So I'm going to take this out like this, and I'm just going to effectively see now what's the behavior of my plane, what are things looking like. So a good thing to do, and again, this is what I suggested in the hints and tips video, is I want to see, I want to take out any elements that might keep looping forever. So we know with a while loop, there's always the potential to loop forever. I want to replace things with a simple for loop. Okay, so I'm going to say I equals 0, I is less than 100, I plus plus. Okay, so my intention here is I want to test, I want to kind of take a step back and see my functionality and see what's going on. I want to actually see why, I want to give a reason for why I'm going to need this extra check. Okay, so I'm at destination 1 and I want to fly towards destination 2. Okay, so we can see that maybe that's not what we want, so we want to actually switch things around. Let's imagine that we're at destination 2 and we want to fly towards destination 1. Okay, so I'm going to change the position of my plane slightly just so I can actually see this working. So I want to go from 5 to 110 and from 30 to 135, so I'm going to quickly change the position of my plane. So we're going to start at 5 and 30, so my plane's at Muscat. Let's imagine that we want to fly back now towards Buenos Aires. Right, so here I'm going to have a very controlled movement of my loop. Let's just start off with 10. I'm going to add some print statements in here, okay? And remember, I really emphasized in the hints and tips video, and I really emphasized to those people who emailed me just how important it was to include these print statements. Okay, so I'm going to literally comment every single line of my program. I'm going to say system.println, start of single flight. Okay. Then I'm going to say system.println, temporary for loop iteration. Then I'm going to print I like this. And then before my if statement, I'm going to print out the values that I want to be testing. So if statement testing plane X with destination X. Yeah. Then I'm going to say system.out.println plane X. And I'm going to say what the plane's X is, coordinates.get X. I'm going to say what the destination X is. I'm going to say that's destination.get coordinates.get X. Yeah, so you can hopefully see what that says. Yeah. And then inside my loop, I'm going to say system.out.println inside first if. Yeah. And then I'm going to say here system.out.println updating planes X coordinate from, then I say coordinates.getX to coordinates.getX plus speed. Yeah. So I cannot emphasize enough how important this print statement process is. It is tedious, I agree, and it would be nicer to be able to step through our program with an IDE, but of course now we're doing things in quite raw fashion, so it's nice to do this, all right? So, and then at the top of my loop, I'd say something like system.out.println, something into but even more detail, say planes X. Actually, I already did this, didn't I? I did indeed, yeah, I already wrote the planes X position, because we're just looking at the planes X position for now, right? So now I'm ready to kind of test what's going on, you know? I want to kind of see, again, I've taken a bit of a step back here. I did a lot of my solution, and you might find yourself doing this. You might find yourself that you've written loads, you're kind of on track with the brief. But here I got to this point where I was talking about wanting to test what was remaining in the distance and check that it was less than speed. And I found that I just needed to motivate a little bit more why this was, and really look at how my program was working in a bit more closely, in a closer way. So now let's run this and see what happens. So here we go. Okay, let's have a look at what we've got here. Yeah, if I can move this up. All right, so quite a lot of output. That's quite nice. So we've got lots of detail here. So let's go to our aeroplane and see what happens. So it's the start of single flight. So now I've jumped over here into my single flight. That's nice. And temporary for loop iteration 0. Okay, so it says here, if statement testing plane X with destination X. I know the plane X is 5 and the destination X is 110. Yeah, so then I can say inside first if. So I know that I've actually satisfied that, which is true because I had 5, my plane's X was 5, my destination X was 110. And I can say I'm inside my first if. Really important to not just simply put ambiguous if statements that could refer to any line. So print statements that could refer to any line. Make sure you say which line you're on, or at least make your print statements different. So you could say line 35 or something like that. Okay, which I advise some of you to do already. So we're inside the first if, and we're saying updating plane's X coordinate from 5 to 17, which makes sense because we're moving in a unit of 12. So we started at 5. We made our plane start at 5. We're moving towards destination 1, which is 110 along the X. Yeah. So now we say updating plane's X from 5 to 17, the addition of 12. And then we go back to the top. Okay, now we're at temporary for loop iteration 1. We can actually see now the plane's position changing, right? We can see it moving right. So it's 17 and then 29, 41, 53, 65, 77, 89, 101, 113, right? Okay. So here we're kind of now showing what would happen if we just left this functionality as it was without this new if statement. So I wanted to show this to you. So we're at the plane's at 101, yeah, and it wants to, its destination is 110. Okay, so we can see this. Let's look at this behavior. So we're on now loop iteration 8. We're now testing X with X, the plane's X with the destination X. We see the plane's at 101 and we see the destination's at 110. So it is true that the plane is still left of its destination. It still needs to move right. It still needs to add its speed in the X. So we say inside first if, so this is still true. Now we say updating plane's X coordinate from 101 to 113. We wanted to be at 110, so now the plane's overshot, right? It's gone right of its destination. It's just missed the runway, you could say, safely, of course, which is not what we want, right? We want it to actually not overshoot. So what we want to say is, obviously here, when we were looking at 101 to 110, the distance here was 9, wasn't it? So we saw that if we were at 101 and we want to move to 110, the distance between those is 9. So if I take 110, which is this here, we can actually bring this if statement back in now. If I take 110, which is my destination, and I minus 101, I get 9. And I want to say if that's less than the speed, so if we're basically saying if I were to continue onwards and add 12 here, which is the speed, then I'm going to overshoot, aren't I? So I want to test, is it still possible for me to increase my X position by the speed and not overshoot? So I can reshuffle that and say, is it the case that the distance between the destination and where I am now, kind of the positive distance, which is 9, is that less than the speed? If it is, then I don't want to move in that speed, do I? Because if I do, I know that I'm going to overshoot, which is exactly what's happening here when I don't have this check. Yeah, so I want to say, if it's the case that the difference here, oh no, this one, the destination X minus the coordinates X, if that's less than the speed, which in this case it is, it's 9, then I don't want to move that full speed, do I? I actually want to go a little slower, effectively. We can imagine a really precise pilot that wants to land within a unit of an hour, so slows his plane down exactly to move that exact distance in that hour. Very precise guy like that, or lady. Then we know that's the behavior that we want, right? So a little bit of a digression there. I'm not going to do this again, so I know this video is probably, time is marching on, but I really want to show you this idea that we can look at our program in detail and see exactly what's going on. I had people emailing me saying, can you help me, look at what my program's doing, and I kind of said to them, look, I advised them to put these print statements in. I mean, it's not me hiding the answer from these people. It would be exactly what I would do to understand their program. So it's a really important debugging process, and loads of people let me know across the week just how useful this was for them. So going forward, if you hit this kind of code that you're writing that has this little element of not being able to quite understand what it does statically, I really would advise you to add these print statements in to help you out. Okay, so what I've done here, just to summarize, is prove that we do need this extra check. Okay, so now I can go ahead and remove these print statements because I've justified, I think, to you the need for this extra conditional inside my loop. Okay, so very nice. Again, I'll just say how important it is to have a more controlled loop when you're testing things. It stops the kind of crazy mad extra output that might confuse you. So now we know if it's the case that the plane is too close to its destination to proceed at full speed, then I need to do something different, don't I? So, but if in any other case, blah blah blah, in any other case, when the distance to the destination, the remaining distance to the destination is greater than the speed, which would be the opposite of this condition here, then I know I can just plow straight ahead, full steam ahead, and land in my destination, right? And actually, you know what I want to do? I'm going to put those, I'm going to put those print statements back in because I want to show you the effect of the new, the effect of this if. Okay, so I'm going to put those back in and add my else back in. I'll put this in here like this. Alright, so then I can run this again and show you exactly what's going on. So if I can't move full speed, I want to be able to move via the remaining distance, don't I? So there's a number of ways to do this. I was personally happy with you just simply saying coordinates.setX. You could say coordinates.getX plus this difference, right? Because that would give you the same behavior. Let's do this for now. So if I want to have this behavior, then that would work. What am I doing? I am missing some brackets. So coordinates.getX. Am I missing some brackets from the end? No, what am I doing? What am I doing? Coordinates.setX, coordinates.getX, destination.getX minus. Oh, don't need that bit, do I? Just looking at the difference, aren't I? Perfect. Okay, so we're saying where I am now, I don't want to move at full speed. So you see this was moving at full speed here. I want to move at whatever the distance that I want to cover is simply what's remaining, right? So I could do this like this. So I could say, put myself another print statement. So out.println distance remaining is less than speed, cannot move at full speed. And then we could say, oh, if I put my speech mark, my speech marks in the right place, we could say system.out.println moving plane to from where it is now, which is coordinates.getX to coordinates.getX. So basically look at all of this. So grab that, stick it in a bracketed section, and we go, there we go. Okay, so now let's run this and let's look at our output and see what we're getting. Okay, so there's something good at the bottom, so I can see my plane has reached its X destination, so something must be going right, which is nice. So again, let's look at the progress. So my plane moves from 5 to 17, moving at full speed, 17 to 29, 29 to 41, 41 to 53, 65 to 77, 89, hits 101. Nice, so it's been moving at full speed up until now. Then I say inside first if, so I'm inside my first if here, and now I see distance remaining is less than speed, so I know I've correctly hit this this top if, which is what I want, right? Because this is when I can't move at full speed. I can only cover the distance remaining. So distance remaining, I cannot move at full speed, so moving plane from 101 to 110, which is nice. We've calculated the remaining distance here. And then, obviously, because I'm using a for loop, this is when it should stop, or when it should then start looking at the y. But here, because I'm using this for loop, I get this extra iteration. Okay, so this is good. This is the behavior that we want. So hopefully that makes sense. I would definitely recommend that you watch that again, or at least speed it up in some way if it took a little long to watch. Type this code out. Use your own if statements, your own print statements. Work out exactly what's going on. Don't just type code out without really kind of understanding what's going on. Okay. So then I get this like so, okay, and put all this back in, and there we go. And really, all that remains now is to do the same thing for right, left, for left, up, and down, right? So I could probably capture some of these bits and pieces in methods. Maybe there'd be a little kind of difficult to do that. I could probably capture this in some kind of private method to avoid some of the repetition, but I won't do so for now. I'll just type things out manually, right? So very, very straightforward process again. So again, I want to check, is it the case that the distance remaining in the x is not what I want, is less than where I want to be? So I say destination, this time coordinates dot get x. Again, I'm organizing the order in which I do my subtractions to make sure that I never end up with negative values, right? So get coordinates dot get x, which is why I said it was fine not to have to use ABS. Okay, so if coordinates dot get x minus that is less than speed, same process again, and I say coordinates dot set x, coordinates dot get x plus again this difference factor, yeah, just like that, and I get this right behavior. Otherwise, I can move at full speed. So here we say, let's put a note for ourselves, can't move at full speed, can move at full speed. Yeah. So again, just make this point that we have to carefully organize the way in which we do our subtractions to make sure we don't end up with negatives. So I know that it's always the case that the plane's position is greater than the destination, so I know I can safely do this subtraction without ending up with negative values, and I'm always carefully working out how far the plane has to move. Okay, and yeah, and then the same for y. I guess I could even speed up here, right? Because the process is hopefully really quite straightforward for you. Okay, and I spotted a mistake as I was doing that, so this should be minus, shouldn't it? So we should minus if we're moving down or left, then this should be minus, shouldn't it? Because we want to minus this distance from wherever we are. All right, I think it's time for a test. Scary, scary. Let's see what happens. Part of me hopes this doesn't work actually, because it'd be nice to show you some debugging. So if you've seen an issue, then you'll be waiting for this to happen, which is nice. So we say coordinates. Oh, if I could spell. Get x and then aeroplane y coordinates dot get y. That's about 5 times I spelled coordinates wrong now. And then we say destination x. Destination get coordinates dot get x. Oh, something else has crept in here. Strange there. And destination y plus destination dot get coordinates dot get y. Get y, yeah. Like so. Alright, so let's see what happens. So remember, where are we flying from? We're flying from 530, so destination 1, which is 110, 135. So we should see some incrementing behavior here. Let's see what happens. Ooh, nice. Okay. So let's print our final destination down here. Final destination. And see what we get. So airplane at 101, 110, 126. Yeah, that looks fine to me. So let's print final destination, final position. Yeah, well, we know it works because of the loop, but just to convince ourselves, let's say final position. Right, again, say aeroplane x, aeroplane y is equal to destination x, destination y. That's the bulk of the complexity now, I would say. The only thing that remains is to track the distance covered, right? There are a couple of ways to do this. I saw people defining fields and then setting total distance to be the distance for one single flight to be 0 at the start of the method. So they'd create a single flight field, or a single journey field, and set that to be 0 at the beginning, and then track it throughout. I think that's absolutely fine. What I'm simply going to do is the following. So I'm going to say here, Well, first of all, let's update our total distance. So let's say total distance. It's going to always be plus or equal however far we move our plane. So we're going to say, I can take this and put that in there. Yeah, so here I know I've moved this smaller increment than speed, so I want to know what that is. And then down here we could do the same thing. So total distance plus or equals, it's simpler here, just plus or equals speed. And then the same down here, we know we've moved that distance in the x and the y. Again, I could maybe perhaps somewhat awkwardly grab this and put it inside a method, but I'm just going to leave it for now because hopefully it's clearer to look at it in this way. All right, so I'm just for safety put brackets around that. So although I'm moving my plane left by this certain distance, the actual distance that I cover is still whatever that distance is. Does that make sense? So say I move my plane, 5 or 9, I think it was before, to the left. And then I don't want to just do where it is now, -9. I want to take that 9 value and add it on to my total distance, don't I? So total distance here, plus or equals speed, yeah, and then the same down here. Total distance plus or equals. Again, let's take this, put it on like so, and then again total distance plus or equals speed, and then total distance plus or equals whatever this changes here. Okay. And then total distance plus or equals again speed. Okay, there we go, right? So we can test this out. We can say system.out.println total distance like this. We can say total distance covered, yeah, plus total distance. And that should be 210, right? Yeah, told you my maths was shocking, just to make sure. 210 is the distance that we want to cover there. Okay, so we're going to say total distance covered, and we want to see that say 210. And you can see here, I have a interesting output. I wanted 210, but I actually got 192. Why is this? Why do we think this is? This is actually an error that I saw a couple of people making. So this is an error now. I've made 2. And what I need to do, the problem that I have is I'm updating the position of my plane before factoring in or taking a record of the total distance, right? This was something I saw loads of people doing. So this error was present for me too. Okay, so now let's run it again, and we get 210, right? So see what I did there? So I added total distance in, either on purpose or by mistake to show, on purpose to show you. I'll let you be the judge of that. And we can see now that what was happening was we were moving the plane's position before actually taking a record of the total distance covered, right? Because obviously this calculation requires or relies on the position of the plane minus or the destination minus the position of the plane. Okay, so if you got, I saw this happen loads of times to people. So if you got this interesting output, this is the reason. Okay, so we switch that around, and we can now see the correct distance here, 210. All right. So next step is just to be able to return the actual single flight distance. Quite a simple step. So we just kind of make a record of what the distance was. So we could say distance at start. Yeah, we can say equals total distance. Yeah, and then obviously at the end, then we just say to calculate what we want to return, we say total distance minus distance at start. So we get the difference between how far was I, what was my total distance at the beginning, and then what did it increase by? So what was my total distance at the beginning, which is distance at start, and then how did it change through the method? And it's that change which obviously gives us the single flight distance, right? So I kind of log the total distance here, and I increase it in some way, and then I log it again, which is obviously stored inside here, and then I subtract the first from the second, and I find the difference between them, so I know how far that single flight has been. Okay, Good. I actually love it when we can look at these issues and work on them and see what might have gone wrong. Really nice. Okay. I believe let's go back to the brief. I think that is the majority done. We just need this notion of repairs now, right? So we had. Let's go back to our flight simulation. Okay, let's take out these prints. I wouldn't suggest submitting these prints to us. It just keeps things neat if you don't. We go back to my flight simulation, and what have I done so far? So I changed some things around actually, didn't I? Just everything. So where was my plane supposed to be? My plane's supposed to be at 110, 135. So I'll put my plane back, and it's supposed to do some stuff now, right? So make your aeroplane simulate its journeys in a single day by doing the following: print the name of your aeroplane and the journey start destination and the journey end destination, which is destination 2. All right, so I'm going to say system.out.println and the name of my plane. What's the name of my plane? So just using the successor method, get name. And we can say traveling from destination 1, so destination 1 dot get name, and then we can say to destination 2 dot get name. So we can see this nice output here. Then we can say, what does it say now? Make your airplane take a single flight to destination 2. So it was flying to 1 before, just in our experiments. And we can say print this single journey distance. I want to wrap this in a nice print statement. So we can say something like travel distance. Remember, we were talking about this idea of both simultaneously printing and returning. Now you can see a really nice use for it, because not only do we call the functionality in single flight, we can also then return this value and print it out to us. Okay. And then we say print this journey and the total distance. So we can say total distance so far. Okay, make your airplane take a single flight, then print this and the total distance traveled so far, and I could just stick this in one line. I wouldn't worry too much about whether you've used new lines or not. I'm sure we'll be flexible in this regard. So total distance, and then plane dot get total distance. Yeah. Good. All right. So and then finally print your plane's current location coordinates. So we can say plane is now out. We could actually say plane.getName is now at plane.get coordinates .get x, and then plane.get coordinates .get y. Okay. Good. And then it's just the same for the other three. Okay, so I'll speed this up again just to keep the actually. Let's test that first. Make sure nothing untoward. So Spirit traveling from Buenos Aires to Muscat, which is right because we start in Buenos Aires and fly to Muscat. Travel distance 210, which is nice. I think we just because we did the opposite journey last time, didn't we? We were going from Muscat to Buenos Aires, so it makes sense that it's the same. Tail distance to that. Spirit is now at 530, which is good because it's at Muscat. Okay, then we're going to do it again, and I'm going to speed up for this just because I'm aware that time is marching on. Let's just check if I made a mistake. So it's going from 1 to 2, so it flies to 2. It's going from 2 to 3, so it flies to 3. It's going from 3 to 2, so back in itself, so it's going kind of in a loop. So it's going 3 to 2, so it flies to 2, and then it's going from 2 to 1, and it flies to 1. You could actually put this in a method. Why don't we do that actually? Let's say private static. Remember, it's fine to segment your driver with static methods, but no other class, because this is effectively just our kind of rough user class. It's a bit different in this assignment because we're looking at repair times. Still, the principle makes the same, so we could say make flight. Okay, and then we can take one of these print statements and put it in here like this. And we could say, a nice thing to say here is if we want to make a flight, what information do we need? So we need to make 4 flights, aren't I? So what information am I going to want to supply? Well, obviously I want to know the plane, don't I? So we need aeroplane. I want to know from, which is destination. Let's say from, and then destination 2. Yeah. So you can see straight away I've got rid of all my errors. Obviously I just need to make this void. And now I can go back and really simplify this, can't I? So I just say each time it's the plane making the flight. Yeah, void static, what's going on here? You can tell it's been a long video and a long day. Public static void. Private static void even. Actually, let's leave it public for now. We've not really talked about the implications of private methods. And we can say plane, and we're going to go from destination 1 to destination 2. Then we say plane from destination 2 to destination 3. And then we say plane from destination say plane from destination 3 to destination 2. And then we say plane from destination 2 to destination 1. I was wrong, there is more work to do down there, as I just realized. So we can get rid of this, and we need to change this from, and then 2, and then 2, and I think that's it actually then, yeah, okay. Ooh, goodness, right, so you see how that's kind of slimmed things down. There was no expectation that you do this in your assignment, it's just a nice thing to show you doing it in this way, right? So save it up there, alright. So Buenos Aires to Muscat, which is what we want, so that's destination 1 to destination 2, and then from Muscat to Zanzibar, and then from Zanzibar back to Muscat, and then Muscat back to Buenos Aires, so we have these kind of round trip, which is nice, excellent. Alright, so now on to the last part. So now repeat the aeroplane's daily schedule of 4 flights, as specified in the previous question, over 120 days. Guidelines for these as follows. So print the current day's number, then print the total distance travelled by the aeroplane up until the start of that day. Okay, so let's do this. So we now know that we've got an actual end to our loop, don't we? So we know that we've got to do 120 of these 4 sets of single flights. So we know we've got a start, which is obviously going to be day 1. We can think about this, as I kept saying on the forum, as kind of a test flight. But naturally, test flights also take distance, so therefore we'll invoke repairs. So we're not going to reset the distance travelled by the planes or anything like that. We're just going to go straight into these 120 days. So we know where we start, which is 1. We know where we end, which is 120. So this suggests that we're going to have a more structured kind of for loop, aren't we? So we say for, we'd even call it days or day. So the first day is day 1. And we want to keep going while day is less than or equal to 120. And we want to increment our day like this. So we start at 1, going up to 120. So we're getting this less than or equals, because otherwise if it was less than, we'd go from 1 to 119. So we keep going and increment our day like that. And there we go. So the first thing it says is to print the current day's number. So print line current day is day. Like that. And then we want to say, and the total distance traveled by the plane. So total distance traveled plane dot get total distance. Yeah. So that's the nice printout that we get. It says now make your airplane complete its 4 daily schedule of flights, which is nice. We've got this pre-made method. We can just pop that down like that. Okay. And then it says, however, the daily schedule should only begin if the aeroplane has not travelled so far a total distance that it needs to be sent for repairs. So we've got this idea that the whole reason we're tracking distance, as I think I've said, is because we want to see, you know, when does this plane need to be repaired, which I'm sure is actually something that they do in the aviation industry. They track how far the plane has flown. And when it exceeds a certain number of flight hours, it needs to be sent for repair, right? Which is 2 things that we're tracking. So what I actually want to say is, there's a condition. We want to talk about the plane, so plane.get total distance, and we want to talk about plane.get repair distance. And we want to say the only way it's okay for a plane to continue flying is if that distance is less than the repair distance, right? So if the plane, if the distance that it's currently gone is less than the distance that it needs to be repaired, then we're going to be okay and we're happy to make this flight. Okay, so obviously we wrap this in an if statement because it's a condition that we want to test to perform some kind of action. So if this is the case, if that's all right, then we make make the flight. Okay, and people are asking, well, what happens if say the repair distance is 1,000, and when I enter this loop, it's on 999 miles traveled, or whichever unit of distance we're talking about. Well, then obviously, pretty much in its first flight, it will exceed the repair distance. It's not something we're concerned about. We were concerned about, really. That's not a level we were thinking about. We're quite an unsafe airline here. PPA Airways is quite unsafe, so even if we were to exceed the repair distance during the day, that's not really a level of abstraction that we were concerned with. Okay, so hopefully we were able to clarify that to you during last week. If you did factor for this, that should be okay. Assuming you didn't change the solution too much, but again, not something that we were concerned about. And in general, we obviously work at some level of abstraction, and we think this is a suitable level of abstraction to work at. So if it's the case that the plane can continue flying, or at least at the moment we're going to quite close our, kind of ignore the fact that it might need repairs during the day, then we go ahead and make those flights. Otherwise, what we need to do is we need to stop the plane flying for a certain time, don't we? So what we can do here, which is a nice trick, is let's read what it says first. So the daily schedule should only begin if the aeroplane has not travelled so far that it needs to go for repairs. If it does need to go for repairs, it shouldn't fly for 7 days, and the total distance travelled should be reset to 0. So what we can do is to kind of simulate the passing of the days here, to simulate the fact that the plane has gone in for repairs, is we can actually manipulate this counter that's inside the loop. So we have this counter, this index variable day, which is tracking the progress of the loop. If I want to effectively skip ahead in time, I want to skip some days, I should try and interact with that. I should try and interact with that days variable. So I need to say I want to update that variable in some way. So I want to say day plus something. Okay, because it's not just the case that this variable is declared inside the scope of the loop statement itself. It's also available for me to access and manipulate inside the loop here. Okay, so if I want to say day, if I want to set this to something, I can do it, and I can therefore influence the way that my loop progresses, the way that it increments. So what I want to actually do is I want to say plus or equals something. And this was a subtlety of the assignment. I don't want to actually say plus or equals 7, which might have seemed like what we wanted to at the beginning. So there's a little test here. Why is this? Well, again, we're trying to work out that you fully understand the way in which a for loop works, right? So we're at day 1. If we were to increment by 7, we'd jump to day 8, okay, which is right, okay, because we've had 7 days of repairs. So the next day that we want to work with is day 8. But then remember, at the end of the for loop, we come along again and we update the days variable here. So if we were to increment this by 7, we'd arrive at day 8 here, and then we'd increment again up until day 9. So we'd actually end up at day 9 here, so we'd be a day ahead of ourselves. To account for this, what we actually need to do, therefore, is only increment by 6. So we've incremented by 6, and then we go ahead and then increment the days once more at the end. Yeah, so little subtlety here. We don't want to increment by 7 because of the way the for loop operates. We always update the index at the end. So if we update by 7 here, this will end up being 8 here at the end, which is not what we want. It will be a day ahead of ourselves. All right, so a little test there just to remind yourselves exactly how a for loop operates. And then the next thing we need to do is we need to reset the plane's total distance. So we say plane.set total distance. So imagine this is manipulating, say, some kind of counter inside the cockpit. The engineers have come in, they've sent it for repairs, and then they reset this total distance traveled inside the cockpit, which will now be used yet again to track whether the plane is or when the plane needs repairs. All right. Final thing. So we want to now keep a track of how many times the plane has been repaired. So we can say number of repairs. Now we can define this as a local variable. So some people were getting concerned. They were perhaps taking this notion of private a little too far. So remember, if we have local variables, we don't need anything like private or anything like that, right? Because when a local variable is inside a method, so it's inside the main method here, it is in itself safe, it's encapsulated. Yes, someone could come along and they could change the value manually at the code, but that's not really the purpose of, or the point of encapsulation. The point of encapsulation is that from outside a class, you shouldn't be able to manipulate the values in fields or in variables. Now, of course, if a variable is declared inside a method, that's never a problem, because you can't grab whatever's inside that method. It only exists for the duration of that method. You can't set it from outside. So I know people are concerned about dropping marks for private, but don't take that idea too far. Local variables are themselves effectively private because they're inside a method. Yeah, so you could have, again, maybe declared this up here, but that would have required it to be a static field, so things just get a little more complex. So definitely fine for this to be a local variable here. And then obviously here, when it's been for repairs, we don't just increase the days, we say number of repairs plus plus, like so. And then once the 100 days have been complete, print out the number of times the aeroplane has undergone repairs. So then we say system.out.println number of repairs, like so. So times plane repaired, like so. And then we say number of repairs. Okay. So times plane repaired 11. Okay, let's see if that makes sense given the numbers that we have. So what was my repair distance? 2550. So you can see we're approaching here 236, 2576. So we can assume this is a bit naughty. It's gone over 2550, but that must have done that during the day. That would make sense if given the distances there. So it's exceeded its repair distance. But then, of course, here we can see, because it gets reset to 0, that yeah, so it comes down to the next day here. It's at 2576, so it finishes the last set of flights there for the day. I can see that. Actually, let's just, no, we can see current day here. So it's at the start of the day here, it's at 2576, and then jumps down to be 110, so 7 days later at 0. So that's exactly what we want, right? So we've increased there by the 7 days that we want, and that's the behavior that we need. And to make things a little clearer, we could just say something like system.out.println. Again, all about these print statements. We could say going for repairs, like this, and then okay, we go, and he's going for repairs, and here we go. So you can see 2576 going for repairs, and then it all gets repaired like that. Okay. But actually, hang on. Something's not right here. So, Buenos Aires to Muscat is 210. Muscat to Zanzibar is 105, but then Zanzibar to Muscat is, Muscat to Zanzibar is 119, but then Zanzibar to Muscat is 105. That's not right, because they should be the same distance. So the things to do in this situation, actually, I'm almost glad this has happened, because it gives me a chance to reinforce this idea. So something's wrong somewhere. So obviously something in the single flight method. So at this point, what we'd do is we'd statically analyze our code first of all and see if we can spot what the problem is. If we can't do that, then it's back to the print statements like I showed you before to iron out exactly what's going on. So you guys have probably spotted this already and have been shouting at your computers. But let me look. So the while loop I think was fine. I suspected something to do with the copying and pasting as always. So destination.getX, if that's less than speed, then that's right, less than speed there. Otherwise, add the speed on. The conditions here are right. Again, getX minus getX less than speed, fine. Then minus speed. Now on the Y, this condition's right. Destination of the get Y is less than coordinates get Y less than speed. Looks fine as well. This condition's right. Coordinates.getY is ha 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 ha. Here we go. So this should have been less than, shouldn't it? You see that there? Because it's always less than speed. What a notorious typo. So there we go. I've got it. That's good. That's nice. That should now be better if we run this. So let's find Muscat to Zanzibar. 105. Great. Okay, so good. So had I not spotted that, it would have taken some print statements and some debugging to get that going. All right. So I guess that was probably one of the difficult things about this assignment was those little errors, those little mistakes, and sometimes it just takes a little time to go through and work out what's going on. So a tough assignment indeed. Well done again for all your hard work trying to get it done and trying to get it complete. The harder the assignment, really, the more you push yourself, the greater you're learning, to be honest. But that said, we'll try and be lenient towards partial solutions because I think this was quite tough. But again, well done for all your hard work. It'll definitely benefit you in the long run. Again, I can't emphasize more how important this print statement idea is to kind of understand what's going on in your code. So I'd say when you're writing this out, try that out, add some print statements, check. So I'm naively, I guess, assuming that everything is still okay here. There might be other errors, so let me know, have a look, and I'll be happy to make additions to the video. Otherwise, thanks, and let me know if you have any questions via the usual means. Thank you.